Hello and welcome to a video on basically finding the gradient of a line, a linear line. So in this video I'll be discussing what the gradient of a linear line is and how to find it given 2 points. So basically we see gradient a lot in these typical linear equations: y equals mx plus c. Now we define m as the change in y over the change in x. Now you're probably looking at that and thinking, what the heck is that, if you've never seen that before or anything, and you're like, why is x changing, why is y changing? Well, we take a look at our normal graph, the graph y equals x. We have an x axis here and y axis here, and this is the graph. So in this graph, every x and y point are equal because x equals y. So if we have x equal to 1, y is also equal to 1. Okay? Now, just taking on to this, our gradient of this particular graph is 1. So our m value for this case is 1. So if we just take a look at this over here and we just bring that, over there, get rid of the c. If we have m equal to 1, we have the graph y equals x. Do we all see that? Oh, whoopsie daisy. Let's move that over there. Actually, I'll just rub that out. Oh, sorry, technical issues. So y equals mx. So for our graph y equals x, our gradient equals to 1. And we said before that our gradient is the change in y over the change in x. Now, depending what our m value is, will determine the steepness of our linear graph. So if we have the graph, let's say y equals 2x, I'll have to I'll draw it on top of it. So the graph y equals 2x, I'll put that on top of this, will look something like it'll still go through the same point. Look something like that. Now, for when x equals 1, our y value will be equal to 2. Because with this graph, 2x, when x equals 1, our y value will be equal to 2. Okay? So depending what our m value is, will determine the steepness of our curve. Alright, so we'll just get rid of that for now. And let's take a look at an arbitrary value, how you actually calculate the gradient of something. So we're saying the gradient is defined as the change in y over the change in x. What does that mean? So let's just take some arbitrary line that is a linear line, and let's say we have 2 points here. So we have x1, y1, x2, y2, and we want to find the gradient. So the gradient is defined as the change in y over the change in x. I say it a lot. So basically, our x value here is going to increase as we go across. Say there's an x-axis here and a y-axis here. Our x value is going to increase. It's going to go from x of 1 to x of 2. So there's going to be a change in x here. Our y value is also going to change depending on our x value. So it's going to go from x of 1 to y of 1 to y of 2. So there's going to be a change in y here. So what is this change in x here? Well, this change in x here is going to be the difference between these x points. So it's going to be x2 minus x1. And the change in y is going to be the difference between y of 1 and y of 2. So the change in y is going to be y of 2 minus y of 1. So reiterating, we know that the gradient is the change in y over the change in x. We know what the change in x is and the change in y is. So our gradient is going to be equal to y of 2 minus y of 1 divided by x of 2 minus x of 1. And that is the formula for finding the gradient of a line given 2 points. So we're just going to get rid of this all now, and we're going to check if that works for our case 1 when y equals x. So let's say, so we got our normal, let's pretend that didn't happen, goes to there, y equals, actually let's do y equals x. So we have, when x is 1, y equals 1, and say 3 and 3. So we have 2 points. We have the points 1, 1 and the points 3, 3. So our formula for our gradient is y2 minus y1 over x2 minus x1. So the way you calculate this is I usually name our points. So I'm going to name this point 1 and point 2. So this is going to be x of 1 here and y of 1 here. And this is going to be x of 2 here and y of 2 here. So using our formula, m is equal to y of 2, which is 3, minus y of 1, which is 1, divided by x of 2, which is 3, minus x of 1, which is equals 1. The top turns to 2, bottom turns to 2. If you divide a number by itself, you get 1. So this shows that the gradient of the line y equals x is 1. Now this works not just for this line here, it works for no matter what m value you have here. Any value pretty much. So we're just going to change our line now, and we're going to change these points here. But we'll see if the rule works for any other line. So let's say we have the line y equals 5x, and we have our points here. We have 1, so our y value is going to be 5, and we have 2, and our y value is going to be 10. So we have the points 1 and 5, and we have the points 2 and 10. Using our rule here, we'll use this exact same rule from over here. But we're going to do the same thing here. We're going to name our points x of 1, y of 1, x of 2, y of 2. So m equals y of 2, 10, minus y of 1, which is 5, divided by x of 2, which is 2, minus 1. That's going to simplify to 5. That's going to simplify to 1. 5 divided by 1 is 5. Cool. Now what if we didn't know our gradient up here, but we got given points? So let's put in some random points and see if we can work out the gradient of this line. So let's say we have the points 1, actually let's not use 1 because that will give it away. Let's say we have 3, 9, and the points 4, 12. How are we going to find the gradient of this line? And let's assume it passes through 0, 0. So there's no c value. So we have our first point here, we have 3, 9, and we have our second point here, 4, 12. When writing your points, always make sure you write your x points first. So these are x points here. Those are x values. So 3 becomes before the 9, and the 4 becomes before the 12. So this is our x of 1, our y of 1, our x of 2, and our y of 2. So gradient m is equal to y2, which is 12, minus y1 of 9, divided by x of 2, which is 4, minus x of 1, which is 3. The top is going to simplify to 3. The bottom is going to simplify to 1. So our gradient is 3. So our equation of this line is 3x. Cool. Alright, so thank you for watching. This is just showing how to find the gradient of a simple equation given this form. In the next video I'm going to be explaining what our c value is for a linear equation, and then I'm going to combine the ideas and try and find the entire equation of a line given points. Thank you for watching.